All right, this is the 2025 Heffernan Exam 2. Let's go through the multiple choice and then the short answer. So, question 1. The asymptote for this graph is when we've got a hyperbola, x plus 1 equals 0, so x is equal to negative 1. Now, the other thing you've got to remember with hyperbolas is that there's two asymptotes. So we've got the horizontal asymptote and the vertical asymptote. So I should be drawing as dotted lines. Okay, so in this case, we've got a negative 1. Sorry, it should be down here. So that means this is going to be answer B. All right, next one. It says let f of x equal this, and you've got the domain. So we need to find the maximal domain. Okay, so the thing we need to consider here is the fact that the denominator, so root ax plus b, needs to be greater than 0. And the fact that we've got something that's greater than 0 means that that's going to be the maximal domain. So if we rearrange for this, we get ax plus b is greater than 0. Ax is greater than negative b. X is greater than negative b on a. So in this case, we've got all the x values that need to be greater than negative b on a, but it cannot be negative b on a because otherwise we'll get 0 on the denominator. Therefore, our answer for this one is C. Next one is a function has the derivative of this given h of pi on 6 is equal to 1. What's the value of h of pi on 4? So for this question, we need to, I guess, find the antiderivative. And we can do this by the cas, or we can do this by hand. But let's do this by hand, and then you can work it out in the cas on your own terms. So we need to work out what is the antiderivative of 4 sine 2x dx. And the antiderivative of this will be, take out the brackets, so 1 on 2, so half, so that's 4 on 2 cosine 2x, and sorry, that's negative, plus c, because the antiderivative of sine is negative cos, and you take that inside the brackets out as 1 on 2. And this simplifies to half cos 2x plus c. And then from here, we need to use the information that when you substitute pi on 6, you get 1. So 1 is equal to half cos 2 pi on 6 plus c. In this case, when we solve for this, we get, okay, so 1 is equal to a half cos pi on 3 plus c. Pi on 3, if we simplify this and solve this, we get c is equal to 2. So you get c is equal to 2. Therefore, when we go back to our equation, which is this one, we can substitute this as 2. And so h of pi on 4 is equal to negative half cos 2 times pi on 4 plus 2. And when we evaluate this on the cas, we get 2, which is C. Okay. All right, next question. This one has multiple ways in answering it. I like to use this way, where we use the determinant. So if we use the determinant, let's take the coefficients a, 8 to a. Okay, and let's call that a. We're trying to find when does the determinant equal 0. So for those of you that know how to find the determinant, it's going to be a squared minus 16 equals 0. Therefore, a is equal to, a squared is equal to 16. A is equal to plus minus 4. Now in this case, we've got to be careful because we're asking for no solutions. So we're asking for two, I guess, completely different equations that when we substitute the values in, we get no solution. They get two completely different lines. So let's test them out. So when we substitute a is equal to 4 into the equation, we get 4x plus 8y is equal to 0. And the other equation is 2x plus 4y is equal to 4. And is that equation? So this one here, so for A is equal to 4, that's a, um, they're not multiples of each other. So in other words, if we multiply this by 2, we get 4x plus 8y is equal to 8, which means that they do not meet. They've got different gradients, and that means A is equal to 4 gives us no solutions. Let's check the other solution. So what happens if we substitute negative 4 into there? We get negative 4x plus 8y is equal to negative 8, and we get 2x minus 4y is equal to negative 4. And let's multiply this by negative 2, and so we get negative 4x plus 8y is equal to 8. Two completely different lines again. So in fact, these two solutions give us no solutions. Be careful with that one, because I think there's a tendency to assume that if one's no solutions, the other one will be infinitely many solutions. So you should double check those answers. All right, question 5. We've got the original graph and we're trying to find the gradient. So for this one, we should probably have a look at what the interval is defined over. In this case, we're defined from negative infinity to a. So that means all the graphs that have anything, I guess, from a to infinity will not be possible. So if we have a look at this, we can reject options B cannot be right, and options D cannot be right. Okay, so we're narrowing down to A and C. So let's see, A and C. Okay, so if we look at the gradient here, as we approach the asymptote, the gradient is decreasing. But if this is the gradient graph, this is saying as we approach A, the gradient's increasing. So the answer for this one is A, because that's the only one that matches up our approach. All right, let's look at question 6. Now, question 6, I jumped straight into the tangent line formula. So it says the tangent to the graph of that at x equals 2 passes through the origin. What's the value of A? So let's use the tangent line formula. So let's go calculator, menu, calculus, tangent line, and we're going to type in y equals, in this case, actually, sorry, no, it doesn't need that. So y equals x minus a power of a third, comma x, comma 2. And we get that as our answer. Now, considering this is a multiple choice question, we need to then go and substitute the point that we're given in, which is 0, 0, because it's the origin. Okay, so from here, let's use solve, open bracket, that, comma, a, but every time we see a y, let's substitute 0 into here and substitute x into here, because it's the origin, and we get 4/3 as our solution. Okay, question 7. This one here tests your understanding of breaking up intervals like this. So I would suggest with this one, we recognize that we can break up the integral from 0 to c of 2f of x minus the integral from 0 to c of dx minus 3 d of x. And since we've got a scalar, we can take that out the front. Okay, and then once we have got this, we can apply this principle where this turns into d, so this becomes 2d minus the antiderivative of 3 from 0 to c. Okay, so that's actually 3c. I'll show you why. Because the antiderivative of 3 is 3c, and we're evaluating that from 0 to 3x, and we're evaluating that from 0 to c. So that's 3c minus 0, and that's why we get 3c there, which means that the answer is 7, D. Okay, question 8. Okay, question 8 talks about scoring 60 practice penalty shots. But if we've got 60 penalty practice shots, we need to recognize this is this is success, there's a number, and there's independence. So we can say this is a binomial distribution. We've got 60 trials, and we've got a success of 0.8. It says given, so this is conditional probability. We've got to use given. Given that he scores a goal for more than 50 of the practice penalty shots, so given that x is greater than 50, the probability that he scores exactly 56, so this one here is x equals 56. And that's probability, and we can do that. So if we now use the, conditional probability formula, we're trying to find where do the first conditions and the second conditions intersect. So they intersect. So where does probability of x is equal to 56 intersect with x is greater than 50? And there's only one place where they intersect at x equals 56. So we're trying to find probability of x is equal to 56, okay, over the second event, which is probability of x is greater than 50. All right, and since we know that this is a binomial distribution, let's use the binom CDF and PDF for this one. So this one here, I'm going to put okay. This is menu, probability, distributions. We're going to use binom PDF for the first one. The number of trials is 60. The probability of success is 0.8. And the x value that we want exactly is 56. And the bottom will be probability, distributions, binom CDF, number of trials, 60, probability of success, 0.8. Lower bound is what's going from, so 51 to 60. Now we don't want to put 50 because it's not inclusive. Okay, and we get the answer 0.0137. Lovely. And that's our answer there. Okay. Now question 8. Question 9. This question here requires normal distribution, mean of 7, standard deviation of 1.5. Okay, I'm just going to draw a quick graph. So if I've got 7, that's going to be 8.5, 10, and that's going to be 5.5, that's going to be 4. Okay, now, the probability that x is greater than 4, so 4's over here, but less than 8.5. So we've got a standard deviation of 1 up and 2 down. So if this is z is equal to 0, we've got z is equal to 1 and z is equal to negative 2, which is answer C in this case. All right, question 10. Question 10 talks about black balls and white balls, which are all identical in size. Martin randomly selects a ball and replaces it in the bag. He does this 3 times. The probability that Martin selects more black balls than white balls is what? So this is a binomial distribution. There is independence because of the fact that there's replacement. We can say X is a binomial distribution, and he does this 3 times, which means it's a sample of 3. And the probability of success is, since it's okay. So how many balls are there in total? B plus W balls, and the black balls is B over B plus W, and the white balls is W B plus W. So in this case, which one do we want to label as success? The success is the black balls. In this case, we'll say the success is B over B plus W. All right. Now, What situations will result in more black balls than white balls? So we could have black ball, and then white ball. We could have black ball, black ball, black ball. We cannot have the situation where we have black ball, white ball, white ball, because we want black balls to be more. So in this case, the only situation is when you get the probability of success is equal to 2 and the probability of success is equal to 3. We don't want probability of success equals to 1 or 0 because that's not what the question's asking. So since this is binomial, the probability of getting 2 is going to be 3 choose 2. The probability of success is b over b plus w to the power of, in this case, we want 2. And the failure will be w over b plus w to the power of 1. So that's that first bit here. Okay, and then we're going to add 3 choose 3, b over b plus w to the power of 3. And this one's redundant, but I'm just going to show you for working, for your understanding, that you can put that to the power of 0. You really don't need to put that last bit there. Okay, you can run this through the CAS, and when you run this through the CAS, you should get the answer to simplify b. All right, this question here, it's saying the graph of g is differentiable when x equals 1. So there's 2 conditions for something to be differentiable. The first thing, it needs to be defined at that particular point. So the point of contention in this case is 1, because that's where the, I guess, supposed discontinuity happens. So we need to work out root x is equal to x squared plus a over b. And when x equals 1, because that's the point of contention, we've got square root of 1 is equal to 1 squared, which will just simplify that. This, and we got b is equal to 1 plus a. And we'll stop at that point for now, because the next thing that we need to consider is when something is differentiable, it means that the gradient as you approach from the left of that point is equal to the derivative as you approach from the right. So in essence, we're finding the derivative, d by dx, of square root of x and d by dx of x squared plus a over b. And we need to make sure that they are the same value. So when we substitute these values in, we're going to find the derivative and then after that substitute 1 in. So let's find our CAS. Okay, so for this one, let's go. Shift minus. Sorry, guys. Okay, so this is the square root of x. And square root of the right-hand side. And we've got x squared plus a over b. Okay, and if we do this, we find that that's our derivative. And then what we can do is we can substitute let x equals 1. So we can say for this one, I hope this works. I'm doing this live. I'm not sure if this will work or not. Let's try that. Given x equals 1. There we go. Because why did we substitute x equals 1? Because that's the point of contention that we want. And now, since we've got this here, okay, and then we can solve. I'm going to say given. Let's see if this works. We're probably better off just doing this algebraically from this point. And what did we calculate before? Given that b is equal to 1 plus a. Doesn't really solve anything for us. So we're going to write this equation here. So half is equal to 2 over b. Sorry, this is Now that I realize, so half is equal to 2 over b. This means b is equal to 4. And then once we get b is equal to 4, I'm just realizing how silly that was. We've got 4 is equal to 1 plus a is equal to 3. And so we get C as our answer. All right, question 12. All right, so from here, we've got the number of transactions in a week for an online retailer is such. So we need to almost graph this equation. And when we graph this equation, we're going to have a look at where is 400, and we need to look at above. So let's see if we can go into new page, graphs, and we've got 420 plus 55 cos. Every time I type a trig thing in, I'm just keeping in mind, is it a radians? Degrees, it's radians, good. So cos pi over 26. Now t, I could use t, but I'm going to use x because with this graphing page, we need to make sure we're using the right variables. And I'm going to restrict this domain. So given that x has to be between 0, do we start at 0? Yeah, we start at 0. And it says first week of the year. First week of the year will be the first, where t represents the t1. So we have to start at 1. So just going back to the question, it says here t is equal to 1 represents the first week of the year. So we should probably start from 1. And it does say z plus here. According to the number of weeks in the 52-week year when there are 400. Okay, so 52-week year. Okay, so we'll graph that. Okay, I can't see it. Menu, Windows Zoom, Zoom Fit. Doesn't look good. I'm going to go Windows Zoom, Zoom Settings. I'm going to change this from maybe 0. My X max will be 54 because my max is 52, but I don't want it to be right on the edge. X scale, I want these to be maybe in ones. My Y min, my lowest value is going to be 420 minus 55. So look, I'll be conservative. Let's say 200, and my highest value will be 55 plus 420. So I'll say maybe 500 can be my highest value. Okay, there we go. Nice graph. Now, while we're on this page as well, just as a little Easter egg, if you want to go menu, view, and grid, and go light grid, it makes things a little bit easier to see when you've got graphs like this. So going back to the question, it says 400 or more transactions. So I'm going to draw another graph. I'm going to draw the line y equals 400. And I'm going to see exactly where these two intersection points are. So I'm going to go menu, analyze graph, intersection, done. I can go control menu, recent, intersection, and I find that month 3 and month 23, or 22 in this case, or it's a bit funny here, there's how many months in between them? So 3 and 22, there's 19 months where it's below. So if there's 19 months that are below, let's go back to our question. So 19, approximately 19 below. Okay, so we're going to go 52 minus 19, which is equal to 33. Okay, so there's 33 weeks where it's above. Now, some of you might be thinking, well, I don't like that rounding because you've got 22.9 and we've got this here, which has got some other rounding. Let's try 23. What's 23 minus 3? That's 20. So there's 20 weeks where it's above. So 20 weeks where it's above. So we could even go 52 minus 20, and that's going to be 32. Well, that's still going to be the correct answer because that's the closest response in this case. So question 12 is C. Ugh. So I'm going to spend a bit of time on this one. This pseudocode question here talks about something called the bisection method. to estimate the root of an equation. So if I read through this equation here, let's look at all our variables. We've got a variable A that we need to consider, B, there's some sort of instruction here, and we've got a variable I, C, and it looks like there's some sort of interaction with all these variables, and we've got an equation here that we can deal with. So I'm just needing to have a look at this. Okay, so this part here, I returns to I plus 1 returns to I. This is like the counter. So in other words, this is the thing that says keep going and move on to the next value. So this is like the equivalent of n. N equals 1, n equals 2, n equals 3. In this case, it's just I. So the variables that I think we need to really consider are the ones that are A, B, and in this case, C. So what I'm going to do and suggest with this one here is we draw up a table. And when we draw up this table, we're going to consider how the interaction between all these variables plays a part into the final answer. So since we did say before I is going to be our variable that's like our counting one, we're going to say 0 because this one's here, it says 0, so we can start at 0, 1, and 2, and I'm assuming this one here says while I is less than 3, but not equal to 3, so that means we have to stop at 2. Okay, so my I is sorted out. Now let's think about A, and let's think about B, because we've got that there, and C. Okay, A, B, and C, and we've got f of A and f of B. F of A and f of B, and we also need to consider if f of C equals 0, then put C, so f of C as well. F of C, but we need to have a look at f of C multiplied with f of A. Okay. Ooh. All right. So the next thing we got to do is have a look at our A value. Our initial A value looks like, according to this question, it says a lower estimate of 0 and an upper estimate of 3. So we're going to start off with A of 0 and a B of 3. Okay, and the next C value, what's the instruction here? A plus B divided by 2. So 0 plus 3 divided by 2, that's 1.5. Okay, let's use our CAS now to kind of complement this idea, because what we need to do is we need to substitute our values for A and B into this equation and see what we get. So I'm going to use my define function. Define f of x is equal to x cubed minus 2x squared plus x minus 2. Okay, so what was the first one? What is f of 0? And what is f of, what was it, 3? Okay, that does not sound right. You know why? I forgot to put squared here. Okay, so let's do that again. F of 0, f of 3. Again, that does not sound right. What have I done? I see what's going on. So, going back to this question, let's read the pseudocode. So this question here is saying, all right, so f of A times f of C is less than 0, then switch out B to be the new C. But if it's equal to more, so it's almost like in a rotating basis. In this case, what have we got? So we need to use not B in this case, but we need to use, looks like we need to use C. So we need to use the C value. So we're going to use, in this case, sorry, I should have said f of C, not f of B. What did we say this one was? -2. And f of C is 1.5. Okay, so that's -1.625. So what happens when we multiply this? When we multiply f of c and f of a together, we get a positive number. Doesn't matter what number is at this point, but why is that relevant? Because it says here, let's bring it up to this point right here. If f of a times f of c is less than 0, make b be the new c value. But otherwise, if it's positive, make a be the new c value. So since it's positive, we want to make a the new c value. So a be the new c value. So we're going to grab that and put that here. Otherwise, if this said negative, we would put 1.5 here. And so now the b value stays as 3, and then we've got to work out what's f of 1.5. Oh, we just calculated that, and f of 3. So what did we get? We get negative 1.625, and f of 3 was, then 1.5 plus 3 divided by 2 gives us 2.25. So 2.25. So f of 2.25 is 1.516. So going back to this, when we multiply these two numbers together, we get a negative number. So since we get a negative number, let's go back to what this means for the next line. It says if x is negative, let b be the new c value. So let's C replace the B value. So in this case, we've got, let's C replace the B value. And so that becomes 2.25, and that becomes 1.5. And so from here, when we do this, we've got to find what's the C value again. So the C value will be 1.5 plus 2.25 divided by 2 is equal to 1.875. So that's 1.875. And then you would do the process again, and then you would update the values. It becomes like some sort of recursive pattern, but something important worth noting here is that it says while I is less than 3. So in other words, this is almost like the final iteration. We don't need to update this next value because it's not asking for that. Therefore, the final answer will literally be whatever your f of c value is. In this case, we've got 1.875. Now, that question didn't need to be as long as what I've explained it. However, hopefully it just makes a bit more sense when we read pseudocode. All right, next question, question 14. So question 14 is saying that it's dilated by a factor of k. Okay, what's the value of k? So at the moment, what are the values? So we've got x squared plus, so minus 16. So what are the intercepts? So we've got x squared is equal to 16. X is equal to the square root of 8. X is equal to, so plus minus square root of 8. Plus minus in this case would be, silly me. Sorry, guys. Square root of 16 is plus minus 2, 4. So from here, what about this one? F of x, we've got upside down graph, and the intercepts will be 2 minus x squared is equal to 0. X is equal to plus minus the square root of 2. Okay, so it's saying the graph of f is dilated by a factor of k from the y-axis so that its image would have the same x-intercepts located at the same coordinates as the x-intercepts of the graph of g. What is the value of the k? So let's look at one instance. We want to turn root 2 into 4. And the other one will be negative root 2. We want to turn it to negative 4. But if we work out one, it will be the same for the other because of its symmetrical nature. So we can use scale factors for this. So where do we want to go, which is 4, divided by where did we start from? Okay, so this scale factor will hopefully then be something that we can rationalize. So this is the correct answer, but we should rationalize it, which gives us 4 on root 2 over 2, which means that we cancel this out. We get 2 root 2, and the answer should be D. Okay, the asymptotes of the graph of this are what? So, to work out the asymptotes, we take the inside of this brackets, which is pi on 4, x plus 1. Okay, and where does the asymptotes occur? We've got pi on 2 plus k, k pi in this case, because there's no domain. So if we rearrange and solve this, we should end up getting x plus 1 on 4 is equal to half plus k. Okay, rearranging this, we get x plus 1 is equal to 2 plus 4k, and then we get x is equal to 1 plus 4k. So 1 plus 4k is equal to x. Therefore, the answer must be D. All right, question 16. Two continuous functions are below. Oh, so we've got two continuous functions are below, and we're talking about fog at x is equal to -1. Ooh. The reason why I like this question is, I'm not sure if you guys are aware, but the chain rule has its derivations with composite functions, such that if we talk about f of g of x, right? F of g of x is fog, which is this. But if you put a dx in front of it, this pretty much becomes the chain rule. So when we're talking about the chain rule, we're talking about f dash of g of x on the inside. So the derivative of the outside multiplied with the derivative of the inside. Chain rule. And now it's asking us to evaluate at x is equal to -1. So f dash of g of -1. Multiply that with g dash of -1. So let's look at our table and see which values we need to use. G of -1. G of -1 is 3, so we can then say f dash of f dash of 3 multiplied with g dash of -1, which is -4. What's f dash of -3? F dash of -3, so f dash of 3 is 6, so 6 times -4 is equal to -24. And we get A as our answer. Lovely question. Okay, probability density function is given by this, and you're trying to work out the value of A. Key thing you need to remember is that the integral from a to 1 of A of g of x, d of x should equal to 1. And then when you solve this on your CAS, you'll find that you need to make sure that you save this, solve this for A. So solve, comma, A, and obviously define g of x as such. You don't need to define the 0 elsewhere bit, and you get the answer B for that one. All right, question 18. Now, this hopefully is in your formula sheet. The volume of a cone is given by 1/3 pi r squared times h. So if we've got pi r squared times h, we need to consider what is this height. So that height there in green. Now, if we want to work out that height there in green, okay, we've got x, we've got 8, and we've got h. We've got h squared is equal to 8 squared minus x squared using Pythagoras. And so we've got h is equal to the square root of 8 squared minus x squared. We don't need to consider the negative solution because we've only got, we're talking about an actual dimension of height. So from here, we can substitute into the h component. So v is equal to 1/3 pi r squared times square root of 8 squared minus x squared. Now we've got to think about this r value. Okay, this r value is, well, x. So since we've got x here, why don't we substitute v is equal to 1/3 pi x squared square root x 8 squared minus 8 minus x squared, and then we solve. We've got okay. So from this point, we've got our formula for the volume of a cone. Now, okay, and so we want to solve when dv dx is equal to 0, because that'll give us a turning point. In this case, that we've got to be careful though. In fact, there's two ways to do this. You could probably solve using calculus. I would actually suggest to save yourself a bit of time, because what I'm trying to say is that when you solve this on the CAS, you still have to determine if that point is a maximum or minimum. You just got to be careful here. I'm going to suggest we graph this. So we get 1/3 pi times x squared times the square root of 64 minus x squared. Okay, and we're talking about the domain, positive domain, so we don't want anything in the negative domain. Okay, so yeah, it looks like I should really be doing zoom out, zoom fit. There we go. And yeah, that maximum. Yeah, okay. So calculus will probably, in fact, if we use calculus, the solution will give you x is equal to plus minus 8 root 6 on 3. And we discard the negative solution, which means that the answer for this one is 10. Okay. Next question. We're talking about Newton's method. Now, Newton's method says here which one of the following should not be used as an initial estimate. So this here is Newton's method. We are really trying to find out when does f dash of x n not equal to 0, because if it equals 0, we've got an undefined value. It'll never reach the x-intercept, therefore never actually generate a new solution. So we need to work out firstly what is f dash of x. F dash of x is equal to 1 plus 1 minus sine x. And if we solve this for 0, so f dash x equals 0, we get sine x is equal to 1. Now sine x equals 1 at pi on 2 plus 2k pi, because we don't want the bottom axis, we just want the top axis. So every 2 pi generates that solution. So which one here could fall apart into that? In this case, A will not be a possible solution because we've got pi on 2. This one won't. It'll be B when k is equal to negative 2 in this case. So negative 2 will give us that solution. Question 20. Question 20 is, we've got a continuous and differentiable function and has stationary points at 1, 0, 3, h3. For the values for x, which h dash of x over x squared minus 3x is less than 0, is given by what? Okay. The best way to do this is to break these up into sections. Now, I like to think of this as section 1, section 2, 3, and 4. Okay, so for the first section, it says here, okay, so we want to find, okay, let's call this section 1, section 2, section 3, section 4. Let's draw up like a little table here. 1, 2, 3, 4. And with these 4 sections, what we're going to do is, oh, sorry. There's actually 5 sections, sorry. We should probably consider the 5th section. The 5th section is over there, so I'm going to write this as 0. Table going at the top. Okay, so we've got to think about the denominator, numerator and denominator. So h dash of x, and we've got x squared minus 3x. And then we need to work out whether or not the overall thing, h dash of x over x squared minus 3x, what the result of that is. Okay, let's investigate. So the derivative of the first part, the derivative of section 0 is negative. The derivative of the first part is negative. Derivative of the second part is positive. Derivative of the third part is negative. And the derivative of the fourth part is negative. Positive. Okay, so x squared minus 3x. So x squared minus 3x appears to be something that we need to substitute into these values. So this is where it becomes a little bit difficult. Okay, so if we go back to our graphs page, let's define, I'm going to define h of x as x squared minus 3x. Okay, so the first interval we need to check is that if it's -1 or something in that negative direction. Okay, so if it's h of -1, what do we get? Okay, we get a positive value. So since we get a positive value, we'll put positive here. Okay, and the next thing we're going to check is, sorry. Now the next thing we're going to check is this section here, where we've got 0 and 1. So I'm going to try h of a half. H of 0.5, and that'll be negative. Okay, so that's negative. And then, oops, sorry, that shouldn't be there. Okay, now section 2, we've got 1 and 3, so I'm going to try 2. H of 2, we get -2. That's -2, negative. Section 3, we've got 3 and 5, so I'm going to try 4. H of 4, that's positive. And the last section is greater than 5, so I'm going to try 6. H of 6. 18, positive. Alrighty, so now we can determine what will the signs be, because if there's 2 signs that are different, this one will be negative. So I'll write in blue. This one will be negative. This one will be positive. This one will be negative. This one will be negative. And this one will be positive. So that means the first section is going to be negative until it gets to the end of the first section. So from negative infinity all the way up to 0. Okay. Now it looks like it'll be positive here. So that means that section's done up to positive. And then that means section 2 will be negative. Section 2 will be negative up until, so from 1 to 3. So section 2 is negative. That's done. Section 3 is also negative, so that means union 3 to 5. And the last one is 4 to infinity, which means that, so 5 to infinity, which means that it's positive, which means that that one stays as such. And keep in mind, the reason why we didn't combine the whole thing is because of the fact that this doesn't have a notch on the bottom. That's why we had to, I guess, exclude 3 at this point. Okay, so D is the correct answer. That's a bit of a doozy of a question. And that's the end of the multiple choice. I'll create a new video for the short answer shortly.